Okay, good afternoon. So this is the first attempt at a online live stream for our ag prep students in the Central Valley. If you're joining, welcome. My name is Jeff Craig, and I'm the math director. You may or may not have seen me or met me at different times at different events. Obviously, with the change in situation for you and for your teachers, and also for our tutoring squad, we wanted to try to offer some support in different forms. So what I'm going to be doing is some work through YouTube, where I'll be sharing my screen and working through some problems. Eventually, these live streams, you'll have the ability to join and ask questions live so that I could react in the moment, but anyone is able to watch these afterwards. So let me practice this. It's first time for me to do this as well, so I'll have to work on writing on the screen, making sure my handwriting isn't awful. That'll be something to adjust. Okay. So today's lesson on the equal sign. I'm pretty sure I scroll this like that. Yes, I do. Okay, well, it's an old friend. This is a lesson that I've run several times when I do college algebra classes at different universities I've worked at. I tend to do this on the first day, talk about the equal sign. I choose that because it's something we use so frequently in algebra, and it deserves some attention in terms of the ways we use it. We actually use it in a couple of different ways, and I think it's important to differentiate between them. So I usually start the class with a couple of questions here, or a couple of statements. Let me number them. So this will be statement number 1. Number 2. Number 3. Okay. So the first 3 plus 5 equals, and we could even put like a little question mark on the right side there, equals something. The second, f of x, and you may be familiar with that terminology, but we'll talk about it in a functions lesson. F of x equals 4. And the third, x squared plus 4 equal to 20. Okay. So I'm going to argue that in my class, often I have people kind of say, what are these equal signs? What's another word for them, or what are they trying to do? So like the first one is very much a process-based equal sign, right? It's somewhat equivalent to at times when you're using maybe a calculator and you hit the enter button. So you do 3 plus 5, enter, or even like it's implied where you hit 3 plus 5 and it just executes it maybe. But it's a process, right? So 3 plus 5, we know this. The equal sign is asking us to do something, to do 3 plus 5. So 3 plus 5 equals 8 would be one use of the equal sign. Now, number 2, this is 2 and 3, very, very common here in our algebra. 1 also comes up, but in algebra classes 2 and 3. It's not necessarily a process here for number 2. F of x equals 4 is actually an assignment. The equal sign is telling you a true statement. So you're not trying to make it true, right? What does 3 plus 5 equal? Well, it equals 8. Let me make that true, and I'll say it's 8. We are being told f of x in this context is 4. So it is a function 4. F of x in this case is actually a horizontal line the horizontal line y equals 4, or f of x equals 4. So it's quite different, right? We're being told now that now in this question or in this problem set, when you're using f of x, the function f, you're talking about the horizontal line 4, y equals 4. And that has a lot of implications, right? Because you could, for example, now do something like evaluate the function f at -1. Well, that would be kind of an equal sign in the type of type 1. That would be 4 in this case, because f of x is always 4. And of course that can differ, and it does very, very frequently. It's at the heart of what we're doing generally in algebra, using functions and understanding them. So number 3 is kind of looking similar, right? Left-hand side looks like a function and it's equal to something, but it is not an assignment of the function, right? It is not saying, f of x, well, there's something tricky going on, right? It's not like we could assign a function to be x squared plus 4. We could assign a function to be 20 and ask when does g of x equal h of x? That's kind of what's happening here, right? This is, I like to often think of like a little question mark above this type of equal sign. It's asking when is this thing true, right? Well, you might be able to see it. I picked this one on purpose. Let me scroll up just a touch, and I think I can come back afterwards, which is really useful. So number 3 again, so x squared plus 4, when is that equal to 20? Well, we can subtract 4 from both sides. So whenever x squared takes the value 16, you can see 16 plus 4 is 20, right? So subtracting 4, we're restating that in a strategic or procedural way. Subtract 4 from both sides, keep the balance. Square root on both sides. X is plus or minus 4. So, or another often written x equal 4, x equal -4. Either will work, right? We can trace it back. Let x be -4. It goes in there. Square it to 16. 16 comes in here. Well, for this whole thing, 20. So it's a different type of equal sign, though. We're going to do plenty of solving equations, so you don't have to worry so much about the specifics there. But recognize that I did something very different, right? In the first one, I executed a problem. What is 3 plus 5? Well, it's 8. The equal sign was a procedure. In the second, it was an assignment. What is f of x? F of x is 4, always. It's this horizontal line. You can see the same type of equal sign as number 2 here and here when I was talking about number 3, x squared plus 4 equal to 20. When is that true? That's what that equal sign is asking. When is that true? So it's a useful thing to think about, right? Because there's so much now we can do, and so much that we'll see. Oh, I don't know how to add more to this. Well, that's all right. I can actually erase. So let me do some erasing here. I'll come back up here. Do some more. Okay. It's, as I said, my first time using this type of thing, so there's probably a lot for me still to learn. So I'm sure it'll get better and better as time goes on here, and I understand what some of these do. All right. So it becomes pretty sophisticated pretty quickly, because oftentimes we'll see like the same types or different types of equal signs multiple times kind of all around each other, right? So like, for example, a problem that says let f of x equal x squared plus 4, the same one we were working with in question 3. Here's a question: what is f of 3. Okay, what is f of 3? So this is in function notation. This is asking if we know about the function f and how it changes its inputs into outputs, like what are its relationship here. Well, we know what it does for 3. F of 3 equals 3 squared plus 4. You can see it probably. X and X, 3 and 3. But this equal sign is the second type, right? It's an assignment of f. F is x squared plus 4. This equal sign is more like, in this secondary equal sign, type 1, right? It's an evaluation process. So it's 9 plus 4, it's 13, right? So f of 3 equals 13. This is a type 2 equal sign. And, you know, look at this though. It's not type 1, but it could be. Now here we're verifying this. This is true. We evaluated it. We found that it's true for this f. But notice something else we could do. We could say, like, I'll put even let here in parentheses because it's often implied, let g of 3 equal 13. And you'll get this type of thing very frequently. You're talking maybe about a graphical problem and you need to graph the point 3 comma 13. You throw it out there, right? You're being told that g of 3 is 13, that 3 comma 13 is a point on the graph of g. It's different than verifying this, right, or establishing it. Here we knew what f was up here, so I'm trying to figure out how to use this pen because obviously I point a lot, so I need to figure out how to execute this. Maybe I could change colors here. So here, like this f situation and f of 3 being 13 is because we were told f of x is x squared plus 4, a little parabola, right? Looks something like this in a little sketch. Goes off. This is a similar type to this equal sign, but not this one, right? Not this one. This one, this one, this one, this one. These are type 2s. We established from the fact that f is x squared plus 4 what f of 3 equals. We had to solve for it. So, you know, attend to that difference. It's going to be somewhat important here as things goes on to be able to recognize there are times when you are told to work under a certain condition here. That's what's happening right here. Right here. Very, very common start to an algebra question. Let f be something. Let g be something. Then do some more things. Okay. Erase this up here. So the second type of equal sign, the third type of equal sign, really, really critical to algebra. And they're somewhat the new additions, right? You've already probably seen this first type of equal sign very frequently. I'll rewrite our first example here. 3 plus 5 equals 8. That's the type 1. Type 2, f of x equals x squared plus 4 in an assignment equal sign. Now type 3, I'll put the question as solve f of x equal to 13, right? That's type 3 again. And just sit with this for a little bit and see the difference here. This is, okay, the 8, imagine it wasn't quite there just yet. This equal sign is asking us to do that, to find the 8. This equal sign is not really asking us to do anything in particular except for be ready to use this function whenever we see this function notation, right? So in that particular question, it can reset, right? Often you will see this accompanied with let f of x be this thing, right? Allow this to be the case for this question that's coming up. Now do something, such as solve. So now what you see here is this type of equal sign is telling us what to do right here, right? That we should replace f of x with the assigned parabola that we were told to let f of x be through a type 2 equal sign. Now this equal sign, in contrast, is type 3. Right? It is asking us to establish the x's, the unknown x values, if any, that make this true. It's a when question. When is this true? Well, it's true when x squared is 9, which is true when x is -3 or 3. So you can, now there's a real subtlety here between these two things here, right? Here we're saying this is a solution to this, right? F of x is 13 when x is -3 or +3, and f of x is this from before. But this is plus minus 3 aren't the only things that x could be. When it's implicit here, x could be any real number, right? So it could be 0, it could be -5.324, it could be any real number. We would plug it in there. But only some of those numbers will succeed in this solving this relationship, right? That f needs to be 13. You can imagine it graphically, right? This is a parabola. F of x is a parabola. The line y equals 13 is, say, there. Well, then this, it crosses it at -3 and 3, meaning f of x crosses the line y equals 13 there, which is a graphical representation of this process. Let me even label this. This is y equals 13. Oh, actually, let me see if that comes up off the side of the screen. It might. No, it looks like it'll work. Okay. All right. So let's do a little where I put the question, and although no one is in chat, I'll give you some time to think about it or even work on it and move from there. So here's a problem. Let g of x equal x minus 2. G of 0 equals question mark. Sorry about that. So question A, g of 0 equals what? Question B, solve g of x equal to 4. Question C, let h of x equal x plus 3. When does g of x equal h of x? Okay, give you a couple minutes to think about this one. Okay, well, let's look at just A here. We can take a break, maybe you've moved on, but let's look at A together. So, well, actually first, let's highlight, just to make a little note of this, all the places that the equal sign is coming up here. Okay, and we should think about what type of equal sign each of these are. And so for A, we have two equal signs that we need to cope with here in order to do A successfully. The first is this one, which is a type 2 equal sign. It's an assignment. G of x is x minus 2, a line. The line y equals x minus 2. And type 1 here in question A. What is g of 0? Well, g of 0 equals 0 minus 2 equals negative 2. So g of 0 is negative 2. Okay, another couple minutes to look at B and C. Okay, well, let's look at B. First of all, what type of equal sign is this one? Hopefully you're all seeing that it's type 2. G of x equal 4. Excuse me. Type 2 happened up here. This is a type 3 equal sign, this one right here. When is g of x equal to 4? When is g of x equal to 4? So just to label this is B. We're solving this. Now you might be thinking to yourself right at this moment, like, okay, what do you do now? Is this an assignment? Is g of x equal to the line y equals 4, a horizontal line? The answer there is no, because we've already assigned g of x up here, right? G has been assigned to be a line x minus 2. For the record, that kind of looks, this is of course a sketch, something like this, that line. So we're solving this g of x right here. What do we do? Well, because we had a type 2 equal sign, we can assign g of x as x minus 2, or we were assigned g of x to be x minus 2. We can bring that in here. Now, if x minus 2 is 4, that means x is 6. Right, add 2 to both sides. Done. That is a solution, right? So often we would put that maybe, or we'd be asked, like, what is the solution? It would look like that. Oh, excuse me. Typo there. Book this was 6. Okay. So pretty good question there. One that comes up, this is a relatively simple form in some case because g was relatively simple. It's just this little line. But the idea behind it is pretty similar in that powerful type of equal sign, the type 3. Very, very important here in algebra. We've assigned g to be something. When is that something equal to 4? Well, you can maybe kind of see it here. 4 would be like this horizontal line, so then this would have to be 6. It happens at 6, right? Okay. Well, last but not least, let's talk about C here. Let h of x equal x plus 3. When does g of x equal h of x? Well, couple of interesting things happening here. One is we are introducing a new function, h. H does things to inputs as well. What does it do? It does this because of the type 2 equal sign. It takes that input and raises it up by 3. So it's another line. It actually looks something like this, right? To think about compared to the previous one. So when does g of x equal h of x? Well, let's take a second here. This is the same g we've been dealing with. It's this one, right? So we can make substitutions here. X minus 2 equals x plus 3. You might already see what's happening here. I think it's critical to show problems of this type because we've done everything right, but this has no answers. Right? We try to solve it like we did before when we were working with, when is x squared plus 4 equal to 16? And that had answers, or 20, I think we did actually. We did a few. Yeah, this has no answers. This one has no answers. Right? We can do the type of thing that we want, so we would say, oh, x, like we'll add 2 to both sides, is x plus 5. You're already seeing maybe the issue here. Well, x is the same thing on left and right. So think of any number you want, same thing on left and right. That is not equal to it plus 5 ever, right? Plus 5 is higher. It's going to be 5 higher. So no answers. And sometimes we see this by proceeding like this. We would try to subtract x from both sides, and we get 0 equal 5, something that is not true, which means for no x's is this going to be true. But it's better actually in the graphical sense, right? They're parallel lines. They never cross. They're never equal. You can see here, this is the line x minus 2. This is the line x plus 3. They will not cross, right? A lot of information going on about why, a lot of ways to know our solution is good, looking at the graph is good, recognize them as both lines with slope 1 is good, so they're parallel lines, they don't cross. All those are good. So hopefully this was a good test run for us today. We'll be doing more, obviously, of algebra and algebra 2 and geometry and statistics, and you'll be watching the ones that are applicable to what you need in your classes. I hope you're all doing all right and taking care of yourselves and your families, and listening to the recommendations of your students, of your teachers and schools. So best of luck. See you next time. Take care.